We're gonna start out in section 1.1 of our book. Problem solving is the idea. And I want to start out with this idea. It's called the 9 dots problem. And I'm going to draw 9 dots. And I want you to draw these 9 dots, the same arrangement as mine. What I want you to try to do is, without lifting your pencil, go through all 9 dots with only 4 lines. So I want you to draw 4 straight lines that go through every one of those dots without lifting your pencil. And see if you can do it. And I want to give everybody a chance to practice and try it. And then if somebody thinks they've been able to do it, what I think I do is just have you tell me, and I'll mimic whatever you tell me to do, and we'll see if it works. I may need to have you turn your microphone on for that. Typing it might be kind of difficult. Not impossible though. You could type me instructions on how to do this, but you might want to just do it verbally instead. But I'll just give you a few minutes and we'll see how it goes. And I don't want to cut you off too early. And there's a couple of things going on here. One of them is the idea that trial and error sometimes gets a bad rap. There may be a more efficient, quote unquote, better way to solve a problem, but trial and error is a reasonable, valid method. And that's what we're doing here. I'm having you try it. You're trying something that doesn't work, you try something different until you get to the thing that does, if you get to the thing that does. Maybe it's impossible. What do you say we go another minute, and then I'll see if anybody's got something they want to have us try. All right. Anybody got something they want to throw out there? Or we just look at it together? Either way is okay with me. Four lines. That's right. And if I would go Luis. If it's Louis, you tell me and I'll make sure to say it the right way. Yeah, 4 lines. All right, let's take a look at this thing here. I'm going to start in the top left. You don't have to, but I'm going to. I'm going to start here in the top left. And I'm going to draw my, let's see if Denise has something here that might do it for us. Oh, okay, Denise. All right, let's look at this together. And struggle can be fun sometimes. So here's how we're going to do this. And you could say there's a trick to this, but I don't think it's a trick. I think it's just a way to solve this problem. So here goes. I'm going to draw 1, 2, 3, 4. And the key here, the thing that you probably didn't do, was you put this artificial barrier up that was inside the box. And the kicker here, in order to solve this thing, in order to do this, You had to go outside of that box that nobody put there but you. There's a little bit of a metaphor here, a little bit of a corny metaphor, but I'll take it, is as we go through this problem solving in chapter 1, I want you to think outside of the box. And so don't box yourself in. It's okay to think outside the box. Exactly, Will, you've got it. And really, that's going to be true in section 1.1 when we're doing problem solving. But you're going to see some things in Math 122 that are probably going to be new and different and a little bit strange for you. You'll probably like a lot of them, but they'll be new and different. So I'm going to need you to have a mindset where it's okay to think outside the box. When you're teachers, I want you to have that mindset with your students, that it's okay for them to think outside the box. We'll try it. If it's a valid problem solving method, great. If it's not, we're going to say, I appreciate your effort there, but that didn't work. But thinking outside the box is okay, and it's something I want to encourage you to do, and this is a beautiful metaphor for that. With problem solving, George Polya wrote a book called How to Solve It in 1945, and there were 4 steps to problem solving that were in that book. Long time ago when he wrote that book, and they still hold pretty well today. Step 1 is understand the problem. Step 2, devise a plan. What am I going to do here? Step 3, carry out the plan. Now I'm going to do it. And then step 4 is look back, meaning, okay, I solved this problem. Did I answer the question that I was asked? And does my answer make sense? So those 4 steps that Polya gives us, understand the problem. Until we know what we're being asked, it's hard to even start at all. Devise a plan. Okay, how am I going to attack this thing? Number 3, do the plan. And then number 4, look back and see if your answer makes any sense. I want to give you a chance to try this. And I don't know, if you've had classes in Big Blue Button like this before, you've probably seen this before. It's called a poll. And what it is it's a way for me to create a problem for you all to try. And then I get to see how you're doing. You get to see how you're doing. I think it's a great feature. And this will be the first of those that we see this semester. You'll see them pretty regularly in our class meetings. So here goes our first one of those. The 261 fifth grade students from a school are going on a field trip. Each bus can carry 36 students. How many buses will be needed? Don't type in an answer. There will be times during the semester where I'll have you just type it in. But for this one, I'm going to create a poll. If you haven't seen this before, it's pretty great. So you should have had a multiple choice question pop up on your screen where you get to respond to this question and say how many buses they're going to need. I love polling like this. Like I said, it's something that we'll do regularly, every class meeting all semester long, except for exam reviews. But for the most part, we're going to be doing polling like this. I love them. It's a chance for you to practice the type of problems you might see in our homework assignments. It's a chance for you to get a sense of, oh, I can solve this. I must be doing pretty good with what we're working on. Or I'm having some real trouble here. I better ask some questions. Or I'm not sure I got it. I'm going to wait and see the explanation. And then if I need to ask questions, I will. Any of those paths are where you'll go with the polling. So it's valuable for you in that sense. For me, it's really valuable when everybody answers the poll question. And this is why it's one of those things where I want to encourage everybody to be in class, because you get to do this and you get to see how you're doing with the material. But it also helps me see where the class is. If we do a poll and more than half the students get it wrong, then I know we need to spend a little more time on whatever it is. If we do a poll and 75 to 90% of the people get it right, then I feel like we're probably in pretty good shape, and I'll go through the explanation and answer any questions. but we're ready to go on to the next thing. And so the polling is really valuable for you, and probably even more so for me. The more people that answer, the better. The more people are in class to participate, the better. Generally, I can see how fast answers are coming in and kind of when they slow down. So I can have an idea that, okay, we've probably had enough time on this one. Generally, what I'll do with these is get to a place where I'll say, we're going to go 30 more seconds and then we're going to talk about it, just to sort of let you know that it's my intention to wrap it up pretty soon. If I say that and you need more time, you can just pop a chat message in there or turn your microphone on and say, I need a little more time. Totally fine. I would rather have that happen and you get a chance to answer it than us to go too fast. I also don't want to take forever doing a poll. We are on this one because I'm talking a lot, but I don't want to take forever on a poll and have everybody kind of sitting there going, all right, let's get on with it already. Can we? That's one of those things where if I'm taking too long on polls, you can email me and say, hey, can we go faster on the polls? If I'm going too fast on the polls, you can email me and say, hey, can we slow down on those polls a little? And I'll try to do what it is that you prefer. Okay, so I think we're probably ready to take a look at this one. So let's see what our results look like here. All right, we have strong agreement on 8, couple of other answers thrown in there. So let's take a look at this problem and talk through it. Keeping in mind Polya's 4 steps, that's kind of what we're talking about here. And first thing we want to do is understand the problem. I think this one's pretty easy, right? We have 261 students that are going to get on the buses, and there's 36 students on each bus. How many buses will be needed? What's the math operation I'm going to do here to answer this question? And you can just type it in. And if 15 people type it in, that's totally fine. What that is to me is me asking a question in class and a whole bunch of hands going up, so I know that everybody feels pretty comfortable. A lot of times in a remote class like this, the first person to type it, everybody else kind of doesn't, and that's okay. I get it. You don't want to type the same thing everybody else did, but it lets me know that everybody's in the same place. Sergio's right about division. Will's got a very important point to make there that we're going to get to. And so we're going to take our 261 students and we're going to divide by 36, since that's how many can fit on a bus. That's right, Katrina. So 261 divided by 36, and we get 7.25. And so you might think, well, 7.25 is my answer. I'm moving on. I did the math thing, so I'm done now. Wait a minute. Polya's 4th step was look back. Make sure this answer makes sense. And Will's correct there. You can't have 7.25 buses. You've got to have a whole number of buses. And so then we're thinking, okay, well, is it going to be 7 or is it going to be 8? Well, this answer lets me know that I need more than 7. 7 buses isn't going to be enough. If I need more than 7 and it has to be a whole number, then our answer here is going to be 8. And so that's how that look back step in Polya's process is really important. That was the most common answer, which is fantastic. But hopefully it makes sense now that you've seen it, that we've got to make sure our answer makes sense. This next one is one of my favorite questions in the whole course. Pigs and chickens. A farmer looks out into the yard and sees pigs and chickens. He counts 24 heads and 80 feet. How many pigs are there? How many chickens are there? I'm going to give you a chance to solve one of these, and you can try to solve this one if you want to. Don't type it in just yet. What I want to use this for is a way to talk about different ways of solving a problem like this. First thing we need to do is make sure we understand the problem. And a pig will have 4 feet and 1 head, and a chicken will have 2 feet and 1 head. And so that's how this becomes a problem that we can solve, is we know how many pigs these animals have. So when he looks out and sees 24 heads, that means there's 24 animals. And you might do this with trial and error. And there is nothing wrong with trial and error. You might find a way that's more efficient than trial and error. You might not be a big fan of trial and error, but a young student might say, I'm just going to try it. There's 24 heads, so I'm going to try 12 pigs and 12 chickens. And Let's see how many feet that is. So if I have 12 pigs times 4 feet for each pig, that's what, 48 feet. And if I have 12 chickens, that's 24 feet. So if I do this, I have 48 plus 24, that's 72 feet. That's not enough. So what that means is I'm going to need more pigs and less chickens. And I'm off by 8. So why don't we try 16 pigs and 8 chickens? We'll change it by 4 and see what that does. And so 16 pigs times 4, that's 64. 8 chickens times 2, that's 16. Sure enough, that's 80 feet. I've solved the problem. There are 16 pigs and 8 chickens. Trial and error, totally worked. You might not think that's very elegant or efficient, and I'll buy that, but it works. There's nothing wrong with using trial and error. It gets a little bit of a bad rap. I probably wouldn't solve this with trial and error, but a kid might, and I don't know that that would be such a terrible thing because they're doing some problem solving, they're practicing arithmetic. Yeah, do it until it works. That's one way to go. There are others. Brianna has mentioned something here that I would never have thought of, but we'll draw it. I need 24 animals. I'm going to start with all of them being chickens. These are their legs. And Brianna, you tell me if I'm doing something different than what you did. 1, 2, 3, 4, 5, 6, 7, 8. So I need 24. So I need 3 rows of that. And that's just a head with legs. Not elegant, but it's getting me to a solution. And so I have 24 chickens there. And like Brianna said, that's 48 feet. Well, I need 80 feet. So I'm going to start turning these into pigs. So I have 48 feet right now. So that's 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Now I have my 80 feet. Oh, Brianna, no, everybody's doing elementary ed in here. That's what this class is. There's no excusing the simplicity here. This is brilliant. I think it's terrific. Yeah, Will, you're right there with me. No, I think that I would have never thought of this. When you're trained in mathematics, this isn't the first place your brain goes. That doesn't mean it's not great. I think this is great. I think a kid could 100% do this. And then you've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 16 pigs and I've got 8 chickens. And I've solved the problem by drawing a picture. We did trial and error. We did draw a picture. Now, trained, those of you who have a strong algebra background might be like, well, yeah, but couldn't you just do 2 equations and 2 unknowns and solve the system? Absolutely. That's what we're going to look at next. Same problem. We're going to set up 2 equations. One of the equations is about the heads. Pigs plus chickens equals 24. The other equation is going to be about the feet. 4 feet per pig plus 2 feet per chicken is 80. And now we have a system of equations. We have 2 equations, we have 2 variables, so we're going to be able to solve it. And the way we'll do it is substitution. You might like what's called linear combination or elimination, and it's fine to do that. But we're going to use substitution. And to do substitution, what we're going to do here is we're going to look at this equation at the top, and we're going to rewrite it for one of the variables. So what I'm going to do is I'm going to say subtract. Let me put it over here on the right. So I have p plus c is 24. I'm going to subtract c from both sides. So they cancel over here so that p is 24 minus c. What that means, equals, means they're the same as each other. P and 24 minus c are the same as each other. And now this is called substitution because wherever I see a p in that bottom equation, I'm going to take 24 minus c and put it in there for the p in that other equation. What we get then for that bottom equation there is 4 times p, but instead of p, I'm going to write 24 minus c plus 2c is 80. Now I have one equation with one variable, and I just need to solve it. Again, those of you who are comfortable with algebra are probably like, oh, thank God, finally we're doing the algebra way. Those of you who don't like algebra might think, I'd rather draw the pigs and chickens thing. Great, fine. Or I'm okay with trial and error. That's okay too. Anyway, let's finish this up with the algebra. So we're going to distribute this 4 through the parentheses. 4 times 24 is 96. 4 times c, that's going to be a negative 4c, plus 2c is 80. Now I've got like terms over here. I'm sorry I ran myself out of room. I've got like terms over here that I can combine. So I have a negative 4c and a positive 2c. So I can combine those, and we'll have 96 minus 2c is 80. And now we're trying to solve this equation. And this is a nice little review for some of the stuff we're going to look at in week 2. But the idea here is I'm trying to get c by itself. So I need to get the term that has c in it by itself. So as I look at the left side of the equation, I'm going to peel that from the outside in. So the first thing I'm going to get rid of is the 96. It's a positive 96. So to make it go away, I'm going to subtract 96 from both sides. On the left, those cancel, and I have negative 2c. On the right, I have negative 16. Last thing I need to do, it's negative 2 times c. So to make that go away, I'm going to divide by negative 2 on both sides. Those cancel, leaving c. And on this side, I have negative 16 divided by negative 2. So c is equal to 8. That means I have 8 chickens. And going back to the very beginning of this thing, if pigs plus chickens is 24, and I know that there are 8 chickens, then I can just subtract that 8 to find out that there are 16 pigs. That's 3 different ways of solving the same problem. They're all good. Whichever one you like the best is the way you should approach it. Trial and error, draw a picture, or algebra. My brain immediately goes here to algebra, but that's the years and years and years of math training. I think this picture approach has some beauty to it because a kid doesn't have to know algebra to be able to solve this problem because they can do it with a picture. You're welcome to use algebra if you want to. Okay, try one. A farmer looks out and sees pigs and chickens. He counts 14 heads and 46 feet. How many chickens are there? I'll set up a poll for this one and let you try it. As you do this, just sort of keep Polya's 4 steps in the back of your mind. Understand the problem. I'm pretty sure you're there. Devise a plan, whichever approach you want to take. Carry out the plan, do it, and then look back to make sure your answer makes sense and it's the one that you want it to be. depending on how you approach this, it might go faster or shorter. If you're doing trial and error and you happen to luck right into it, then you solved it pretty quickly. Uh, some of you that might be trying the algebra just to sort of see if you can shake the rust off. It might take a little time to get that rust off. That's okay. And then next week, after we only have the one class meeting because of Labor Day, but that's when we'll be doing some practice with some elementary algebra. We don't do a lot of it in this class, but I want you to be comfortable with some basic things. Let's go another, let's say 35 seconds on this one, and then we'll talk through it together. If you need more time, just send me a message and you can have it. All right, let's see how we did on this one. Okay, not unanimous, but strong agreement. That's typically where we tend to come in on most of our polls, is not unanimous, but strong agreement. Strong agreement isn't always right, but a lot of times it is. And so let's take a look at this one together. If you drew a picture or you did trial and error, I'm pretty sure you're comfortable. So I'm going to do this one the algebra way, but if you want to see it a different way, you just let me know. So let's see here. We have 14 heads and 46 feet. I'm going to do this so I have better space here. So for feet, I have 4 feet per pig plus 2 per chicken, and that's 46. And then for the heads, just pigs plus chickens is 14. And in order to get one of the variables by itself, last time we did C, this time we'll subtract P from both sides. If I subtract P from both sides, these cancel and I get C is 14 minus P. And so since C and 14 minus P are equal to each other, then wherever I see a P, I can replace it with 14 minus P, and that's what I'm going to do up here in the original equation. So I'm going to have 4P plus 2 times, instead of C, I'm going to write 14 minus P, and that's 46. Now I need to solve this equation. We'll start by getting rid of those parentheses by distributing this 2 through them. We'll have 4P plus 2 times 14, 2 times negative P, and that's 46. Now I have like terms here that I can combine. I've got a 4P and a negative 2P. So I can combine those and have 2P plus 28 is 46. And now we're trying to get P by itself. So we need to get the term that has P by itself. And as I get to learn you, I'll know how detailed I need to be with the algebra. But for now, we'll be pretty detailed. I'm going to subtract 28 from both sides. Those cancel, and I've got 2P is whatever 46 minus 28 is. 18. Divide both sides by 2 and end up with P is 9. Then I have to be a little bit careful because I have 9 as an answer, but that's the number of pigs. And this question said, how many chickens are there? I want to make sure we answer the question that we're being asked. And so how many chickens are there? Well, if there's 9 pigs and there's 14 animals, then you can either set it up as 9 plus C is equal to 14 and subtract 9 from both sides, or you could just do 14 minus 9 to find out that there are 5 chickens, and that's our answer. It's an Apple Pencil on an iPad. It's not as neat as I would like, but it's not bad. It kind of slides around a little. I wish I could be a little more tidy. I'll do my best. Sometimes if I go slower, it's a little neater. But if there's anything you can't see ever, you just tell me and I'll rewrite it for you. Okay, we did well on that. Does anybody have questions? Does anybody need anything cleared up on that pigs and chickens question? Oh, right now it's not fancy. I wish it were a little fancier and would tighten up my writing, but I haven't really crossed that line yet. Okay. Last thing I want to say before we wrap up today is a couple of notes about the homework assignments. On page 20, in order to solve number 11, you'll have to make some assumptions in there to solve that. What that means is you might not get the same answer as somebody else, depending on whether your assumptions were the same as theirs. That's okay. Here again, we're thinking out of the box a little bit, and I had to make some assumptions, so my answer might be a little different than somebody who made different assumptions. Also, in there, there's some